I'm Anil Kumar, and here is a very interesting question on curve sketching. You need to sketch graph of the function f of x equals to x divided by square root of x square plus 1. Now you could use calculus, find derivatives, first and second derivatives, and sketch a graph. I'm kind of making a simpler sketching exercise so that even grade 11 students can take it up. So what we will do in this particular video is we'll only utilize asymptotes and some of our knowledge on domain and range to sketch this particular function. We are given the function f of x equals to x over square root of x square plus 1. As you can notice, denominator is non-zero and always positive, right? So what we have here is a condition where domain has no restrictions. So first thing which you notice here is that the domain for our function is that x belongs to real numbers, right? That is the domain. Now as far as the range is concerned, approximately what you notice here is that square root of x square plus 1, so this is slightly bigger than the numerator, right? Now numerator x value could be positive or negative. So if it is positive, we are kind of approaching 1. If it is negative, we are approaching minus 1. So the range will be y belongs to real numbers, where y is greater than minus 1 and is less than 1, right? This inference is slightly difficult for some students, but anyway, if you find it difficult, you can kind of skip it for now. Okay. Now another part which we can find is x and y intercepts. So we can find the value of the function at 0. So if I substitute 0 here, I get 0 over something, so it is 0, right? So we get f of 0 as 0. Now let us sketch, let's plot coordinate planes here. So this is our x-axis and y-axis. Now what we will do here is we'll consider the end behavior. End behavior is what happens to this function, which is continuous function. We see domain is all real number. There are no discontinuities. So that also means continuous function, right? End behavior is what happens when x is very large. If x is very large, approaching infinity, kind of positive infinity, in that case what happens? In that case, if x is very large, then what we find is that f of x approaches, if I write a value, let's say 1000 and calculate, I'll get 0.999, right? And then calculate. If I write 10,000, we are approaching 1. So we say f of x is approaching 1, right? You can use calculator to calculate. So what you can do is you can find what happens when you write f of 1000, right? That's a relatively large number. So you have 1000 divided by square root of 1000 square plus 1, right? So when you do that, you get a number which is 0.999. So it is approaching 1. Do you see that? So that is how you could find this end behavior. The other side is, so you're approaching, but you're not quite there. Do you see that? You're approaching. What happens when you're approaching negative infinity? So for that, we can try to find the value f of minus 1000, right? So this time, let me again calculate the value, and this time I will do minus 1000 on the top, and then divide by square root of within brackets minus 1000 square plus 1. So in this case we approach minus 0.999. So basically what we find that at this stage the function f of x is approaching minus 1. Do you see that? So as it approaches minus 1, it is not quite there. So what we found here is that when you are approaching large positive value, the function is approaching plus 1. On the other hand, if you are approaching a negative value, the function is approaching minus 1. So these points for us are 1 with a negative sign, and this is 1 positive. Correct. So the value of the function, now you can clearly see the range is between minus 1 and plus 1. We call them horizontal asymptotes. So we have two horizontal asymptotes here. So one is y equals to minus 1, the other one is y equals to plus 1. So these are the horizontal asymptotes. Now when you sketch this particular function, we are approaching from down, and when 0 we have this point. So you'll find the graph is kind of like this. Now to sketch this graph, what you can also do is take up some points. So if I take some values of x and then calculate, so we'll get points in between, and then that will give you kind of structure or the curvature of the graph. So it should look kind of like this, right? So this is your x-axis and that is y-axis. Now in one of the other exercise which I have taken same function, what we will find is that we'll use calculus to sketch this graph, especially to find the curvature. So we are saying that this side is kind of concave up, this is concave down, and there's a point of inflection at this point. So to find all those things, what you can do is you can find the first derivative and you can find the second derivative, analyze these derivatives. Second derivative gives you concavity. The first derivative gives you local maximum or minimum. So you'll find concavity at a point using the second derivative. So we are not getting there at this stage, but I'll provide you with a link so that some of you who are doing calculus can actually apply the derivatives and accurately sketch this graph of x over square root of x squared plus 1. I hope that helps. Thank you and all the best.